Hi, welcome to this deep dive into IBM Spectrum Protect's directory and cloud container storage pools. I'm going to start by talking about why Spectrum Protect introduced container storage pools and the different type of container storage pools are out there. Then I'll go into the way that the Spectrum Protect server manipulates the data that's put into the Spectrum Protect container storage pools. This includes server-side deduplication, compression, and encryption. Next, I'll take a look at how to protect the data that's being stored in those storage containers. And this will include the protect storage pool command, the replicate node command, and copy to tape. I'll take a brief look at how Aspera FastP interacts with the container storage. And finally, we'll take a look at converting data from legacy storage pools into the new containers. Container storage pools are a fresh way of storing the data that's being backed up, archived, space managed, or from some of our database or application backups that's being managed and stored in Spectrum Protect. When we look at storing data inside of these containers, first and foremost, you have to remember containers equal deduplication. So if data is being stored in a container, it is automatically trying to be deduplicated. Now, we'll talk about this in a bit. Not all data will be deduplicated, but containers equal deduplication. The containers themselves are handling storage in an automatic fashion so that we don't have to directly manage that storage. So basically, we're going to write it once, and then we're not going to fuss with the data that's out there. So this gets rid of things like reclamation, migrations, copies, shredding, land free. All these types of manipulations we used to do and are still available in the legacy type of storage pools, the file, the volume, the tape storage pools. With the container storage pools, we do not have any device classes or volumes that have to be defined like you would do with legacy random or sequential access storage pools. All of the containers are dynamically created and deleted inside of the containers. Spectrum Protect brought to the table inline dedupe on the Spectrum Protect server. We've had previously out-of-band dedupe on the Spectrum Protect server, but containers bring to the table inline dedupe. In addition, we've introduced LZ4 server-side compression, as well as a server-side encryption. So the goals of the next generation containers include easier management, faster performance, more scalability, and the introduction of cloud storage without any type of gateways. When we compare our legacy storage pools to our new container storage pools, here are some of the differences that you'll see. With our legacy pools, storage pools that use a device class to identify the device that the pool uses to store data. The device class has numerous options for tuning and usage depending on the device it represents, and it could be connected using things like fiber channel, Ethernet, or FICON. Those legacy pools could either be random or sequential access. They could have been primary pools for primary backups or copies of those backups. They perhaps were using volumes or tapes or VTL type of structure. And if we did deduplication, it would have been in a file device class and it would have been supported out of band. Now we do still support that, but we're going to differentiate it from our container storage pools. And finally, the legacy pools were at an object level of management. Now let's take a look at our container pools. When we talk about containers, there's two types of containers. We have a directory container that uses file system directories that map to storage devices associated with the Spectrum Protect server. We also have cloud containers, and these could be either on-site or off-site cloud providers. And when we write to cloud containers, we write to them in an object format via the TCP/IP connection. Our containers are primary only. We'll talk about a few exceptions there. Instead of using volumes, we'll talk about containers inside of the container pool. It does support inline dedupe. In fact, inline dedupe is the default. You can't turn it off. And we shift from an object level management to an extent level management. And this helps with the optimization of the lifecycle handling, as well as faster and more granular recovery of a storage pool. First, let's take a look at directory containers. Now, as I go through this presentation, I'm going to be very specific about whether options and features are supported in directory versus cloud containers, because you will see in some cases there is a difference. So first of all, directory containers. These are going to be file-based local storage, and the amount of free space that's available is the assigned storage pool directory. So when you assign a directory to a directory container, we assume all of the space in there is for our utilization to store data on. The directory containers are hybrid of the disk and sequential that you would have known from our legacy storage pools. So they're managed like a sequential type file volume, but we don't have to deal with reclamation. And then data extents are stored in a random fashion like we do on disk volumes, but we don't have the disadvantage of a static footprint and lack of variable sizing. When we write out to a directory container, we'll utilize existing containers with free space until that is either all used up or until that particular container is full. And we are able to distribute data across multiple directories. So when you define these directory containers, you can specify multiple directories underneath them. And this will allow us to do some load balancing and improve our I/O performance if those directories map to different physical disks. You do not want to assign a directory to a directory container that's on the same physical file system as the Spectrum Protect database or log. This is because the storage pool container directory can grow to use more space on that file system. Now, directory containers must have an overflow pool, and these overflow pools can either be a cloud pool or a primary pool on disk or tape. And an overflow pool is not a next storage pool like you'd have in our legacy. Overflow pools would only be used if the directories are out of space or if the object we're trying to write to that directory container is larger than the max extent size. And here at the bottom, I do give the command line for defining a directory container. And once you've defined that directory container, you would then define the directories underneath that container with the defined storage pool directory command. Container storage pools. Now I'm going to talk about the cloud containers. Cloud could be either on-premise or off-premise, and the only real difference between on-premise or off-premise is who is managing the cloud and what type of cloud it is. We write out to the cloud in an object format and do not require any type of cloud gateway. We do support, as of version 8.1, S3 IBM Cloud Object Storage, previously known as CleverSafe, S3 Amazon, SoftLayer, Swift, and V1 Swift. We only support these two clouds using the S3 protocol. You will see in the near future here a procedure that other vendors using the S3 protocol will be able to verify that their cloud works with Spectrum Protect. So cloud containers are mostly based on directory containers. We utilize the same deduplication and chunking. We do create the containers in the cloud automatically, and we consider the size to be infinite when we define a cloud. You can go out there and predefine buckets and vaults, and I'll talk about that here in a bit on how you do that for your S3 Cloud Object Storage or Amazon. One thing to remember is that anytime we're writing to the cloud, we are very dependent upon the network and any other external factors that influence that performance over the network. So for instance, if you had a smaller network pipe or OpenStack Swift environment that's underpowered, that would create a very slow result for Spectrum Protect writes out to the cloud. All of the deduplication, compression, and encryption is done prior to sending the data out to the cloud. When it comes to encryption, we do require that for an off-premise cloud, and we do highly suggest it, but it is optional for an on-premise cloud. Here is the defined storage pool command you'd use if you wanted command lines to define a storage type of cloud. And notice you'll need things like your cloud URL, your ID that's associated with that cloud, passwords, and so forth. And I do have some special instructions when it comes to defining CleverSafe or Amazon cloud containers. When we write out to a container, whether it's directory or cloud, we are now utilizing something called extents. And extents are basically pieces of data that's going to be stored in a container pool. They could be composed of metadata or file data. They could be deduplicated or not, and they can vary in size. We do have a sliding scale window that's optimizing the size of these extents during the ingest of the data. The extents by themselves are meaningless. You really need multiple extents to create a whole object. The extents give Spectrum Protect the ability for deduplicating and storing data, and so it easily allows us to match previously deduplicated portions so that we don't have to constantly restore that data. There are extents that will be non-deduplicated. This would include things perhaps that were encrypted on the client side, and therefore we could not deduplicate them. The size of the extent, as I said, is variable. We see about 50 KB as the minimum extent size, 4 megabytes is the upper size, and somewhere in between around 256 KB is our target average. For files which are smaller than 50 KB, a single extent is used which matches the file size. And for files that are smaller than 2 KB, we don't even try and deduplicate them. If you're asking about the size of writes out to container storage pools, it's still 256 KB. That's a good number to work with. And for writes to the database, the size is going to vary from 4 kilobytes to 32 kilobytes, depending on the table. But if you're trying to tune it for your installation, then go with 4 kilobytes. Now, along the way, I was showing you some of the command lines. Our Operations Center has built-in wizards for walking you through the definition of the containers. So if you go into the Operations Center and you go to the storage pools, and then click on the plus storage pool icon, that will allow you to define a storage pool. And in that screen, you'll be able to decide if it's a container-based or if it's a traditional legacy storage pool. One thing to note is if you are creating a directory container pool, all of those directories you will define to it do need to be predefined. And those directories have to have read-write privileges. For cloud containers, you will need a lot of the cloud-specific information, like the URL, like the passwords, like the IDs that are associated with that cloud. On slide 12, this just gives you an overview of the CleverSafe Cloud Object Storage interface and what kind of information you would need to define that to Spectrum Protect. The ID and password are the API key and API password, and you would get that from the Cloud Object Storage interface. This is a picture of the Cloud Object Storage interface here. We do have some white papers and some videos dedicated just to setting up the Cloud Object Storage with Spectrum Protect, so check those out if you're looking for more information on that. For Amazon, same thing. We do have a white paper out there that talks about how to first configure Amazon, and then taking that information, you'll be able to easily plug that into the Spectrum Protect Operations Center wizard so that we can define that as a container. One thing to realize is that the cloud URL is going to be the Amazon region endpoint. And as long as you have not pre-specified buckets or vaults out on the Amazon site, you can basically pick any of the regions. But if you have predefined a bucket or a vault, you'll want to make sure to utilize the URL that's the same as you predefined that bucket or vault. Speaking about predefined containers, with many S3 vendors, you can go out there and predefine these buckets or vaults through the Cloud API. And the reason that many users like to predefine these buckets is if there are special policies, if there are special access rules or such that they want to implement, they want to do that on their own prior to Spectrum Protect accessing those. It'll also allow multiple Spectrum Protect servers to use the same space out there on the bucket. And it allows for each storage pool inside of Spectrum Protect to have their own buckets. If you could either have multiple storage pools using one bucket, you could have each storage pool having its own bucket, but you cannot have one storage pool having multiple buckets. When you go through the Operations Center wizard to define a container, it will give you the option to define a bucket name. Now in version 8.1, when you enter a bucket name, we will actually go out and validate the preexistence of that bucket. And the reason for this is we want to confirm that the admin does have all the proper credentials to access that bucket. And if the bucket did not already exist, the Operations Center will actually attempt to create that bucket. The next few slides are going to walk you through some of the command line commands that have been implemented around the containers. The first is the move container command. This might be needed if you had a directory deleted, if a container was damaged, if you upgraded your hardware from one type of hardware to another, or if there was some type of I/O errors on the disk where your directory container was. The audit container checks for inconsistencies between the Spectrum Protect database and either the cloud or directory containers. And it'll go through and it'll mark any of those damaged extensions needing repair. The audit container command will not run if an actual repair is in progress. And you do have a couple different options when you run this audit command: the scan all, the remove damaged, the mark damaged, or the scan damaged. The query damaged displays information about the damaged extents that were found during that audit. And this would include things like the client's name, directory, file spaces, node names, etc. And I'll talk here in a minute about how you would actually repair those damaged files if we do find some. The query storage pool directory will show you the directories that are assigned to a directory container and what their status is, if they were read-only or destroyed. Another thing we have introduced for the cloud containers is the concept of a hybrid cloud. And a hybrid cloud basically takes our cloud containers, but on the front end, it adds some disk space where we stage the backups to. And then as the network becomes available, we feed the data out to the cloud container. The reason we introduced this is that we found the biggest bottleneck is the network. And so by having our backups complete more rapidly to a directory container space and then just using that as a holding space until we can feed it out to the web, we were able to improve our performance. In addition, starting in version 7.1.7 for the S3 protocols, we were able to bunch the data together into a 1 GB container and feed that entire container out across the web at one time. And this improved our performance for the S3 protocols. This is in comparison to the other protocols where we still have to send out individual extents across the network, which does not give you as good a performance. For these hybrid clouds, we support all of our Spectrum Protect servers, and all of the different clouds we support can utilize a hybrid cloud staging area, but only the Amazon S3 and the Cloud Object Storage will be able to take advantage of the large object support where we feed the 1 GB chunks instead of the individual extents out across the network. Now the size of the space you're going to carve out as a staging area really depends upon the speed of your network. If you have a really fast network out to the cloud and your staging area is emptying out pretty fast, then you need a relatively small staging area. Versus if you have a slow network where we're going to have to trickle the information across that network out to the cloud. When we write out to this staging area, the data is written out as deduplicated and compressed and encrypted, and then when it's ready to go across the network, we just have to send it. If you were to look at the data, when we write it out to this staging area, we do update the Spectrum Protect database with the initial location of it being out in that directory. And then as we move it across the network and the cloud comes back and confirms that it's been written, we'll then update it with the cloud location. You will also see a process that shows that local to cloud transfer is running, and multiple threads can run against a container at one time. When we've written that data out to the cloud, we do delete it off of the staging area. We don't keep it around or cache it. So we move this data when the network's available and when we have a container is written to the full extent. For the S3 clouds, we will start moving the data across the network once the data in the staging area fills up the container, which is about 1 gigabyte, or if that data has been sitting there for a while, we'll flush it out. When we write the data out to the network, we do lock that container, and we do have an S3 transfer manager that's going to work with us to write the data out in parallel to the cloud. Now, the name of the objects will be recorded before we start the move process in case there's some kind of network or server crash. Once it's reached the cloud returns a unique E tag, and that's the information we'll update the Spectrum Protect database with. So once the upload is complete, any future reads against that data are going to be directed out to the cloud. We do store the offset and the length of each extent in the Spectrum Protect database. With version 7.17 of Spectrum Protect for the S3 environments, we also enabled the Async Restore. So in conjunction with our large object uploads and our async restores, we did see an increase in our performance times for writing data out there. So you'll see here on slide 37, the writes out to a directory container versus out to the cloud are pretty close. The restores are still a little bit slower, but the performance has shown improvements with the async restores. Let's take a look at how the Spectrum Protect server manipulates the data that's being written into the containers. We're going to look at inline dedupe, server-side compression, and server-side encryption. So the inline dedupe is an efficient way to write the data out to the containers, both directory or cloud. And the inline dedupe will occur during the client backup or the replication operation. And data is going to automatically deduped as it's ingested into the container. We don't have any out-of-band processes running, and we don't have any need to reclaim space out in those containers. We can still utilize client-side dedupe, so if you do want to run the deduplication on the client prior to sending it to the Spectrum Protect server, our inline dedupe will work in conjunction with the client-side dedupe. We do still have our out-of-band deduplication available for the file device classes, but it's not as efficient as our inline dedupe. In order to enable dedupe, first and foremost, remember, if you have a container, it's automatically enabled for dedupe. If you want to enable server-side inline data deduplication and not have client-side enabled, you would, on the client, make sure the deduplication was set to no. And then on the server side, you would simply go out and define your new containers and the storage pool, and then make sure you update your copy group to have your destination be one of those container storage pools. If you did want to allow client-side dedupe, then on the server, you'd have to do the register node dedupe equals client or server, or you could do an update node dedupe equals client or server. And then on the Spectrum Protect client, in the option file or the sys file, you'd have to update it with deduplication yes. And this would then allow client-side dedupe to work in conjunction with your container inline dedupe. The Operations Center has been updated to easily give you information about the savings you're receiving from the inline dedupe. If you go into the Operations Center in the storage pools, you'll simply see a % savings column. And if you hover over that, you'll see the bytes saved and the ratio. At a storage pool level, you can also issue a query storage pool format equals detailed, or issue a select storage pool command to see those same savings. If you want to see the dedupe at a node level, that is a little bit more complicated. We do have the ability to run this generate dedupe stats. This is a I/O intense process and it'll take a while to complete. But once it completes, you can issue the query dedupe stats, and that will show you dedupe stats at a node level. One thing to know is that we do keep these dedupe stats in our database. If you wanted to get rid of one of those stats, you would run the delete dedupe stat command. If you wanted to see the dedupe stats at a session level, then you could use this select command. We just talked about deduplication. Now let's look at compression. In version 7.15, we changed our compression from LZW to LZ4, server-side compression. And LZ4 is more efficient than our LZW. The nice thing about using compression in conjunction with deduplication is you're going to see your savings ratios increase. Previously, we had client-side compression, and that is still supported. But what we're talking about here is Spectrum Protect server-side compression. If you want to turn on server-side compression for a container, you would do either the define storage pool compression equals yes, or you could do the update storage pool. Now, one thing to remember is that if you already have data in these containers, we will not go back and recompress the data that's already there. This will just be for new data being written into the container. As these data extents are ingested, we do examine them, and if they're not suitable for compression, we will not compress them, i.e. metadata extents or data that was previously encrypted or compressed on the client side. The order we go is dedupe, then compress, then encrypt. This slide gives you an idea of the fact that when we run deduplication in conjunction with encryption, we drastically increase the amount of space savings. So for instance, if you were receiving a 2-to-1 dedupe rate, and then on top of that a 50% compression result, that's going to, in the end, give you a 4-to-1 space savings rate. Another thing to be aware of is that CPU impact of compression, and we do take a hit, about 30% CPU cost for using compression. But the trade-off here is that if you're writing this data out to the cloud, remember the cloud's biggest constraint is usually the network bandwidth. And so if you're sending less data across the network, then the CPU you utilized for doing compression will have the payoff of less data being pushed across the network. If you take a look at our blueprints, we do include in them sizing considerations if you want to utilize compression. Some of the commands around compression: a query storage pool will show the compression ratio. Query dedupe stats will show the compression ratio statistics also. And you can also run a select from the storage pools to see your saving rates. One thing to note, if you run an audit container, that data will have to be uncompressed before we can examine it for damage. In the Operations Center, if you hover above the savings column, you will see the overall savings. You'll see the amount that was originally backed up, what it was reduced to after deduplication, and then what it was reduced to after compression. Now, the Spectrum Protect clients prior to version 7.16 only understood LZW compression. So if you want to be able to send compressed data from the Spectrum Protect server to the Spectrum Protect clients or vice versa, be at version 7.16 or above on your client side so that you take advantage of the LZ4 compression on both the Spectrum Protect server and Spectrum Protect client. We just spoke about compression. Now let's take a look at server-side encryption. Server-side encryption is currently enabled for cloud containers only. It is not currently enabled for directory containers. In order to enable encryption, you do need to say encrypt equals yes or no when you're doing your define or update storage pools. And then once encryption is enabled, all new data that we write out to that container will be encrypted. We do not go back and re-encrypt data that's already in that pool. If you're utilizing node replication between two servers, currently those servers don't understand each other's encryption keys, so the data will be unencrypted before it is sent across to the second server. We do also support client encryption. It is handled differently from server encryption. So first of all, the server controls the encryption at a storage pool level, whereas the client controls encryption at an object level. The server is going to manage all of its own encryption keys, whereas the client optionally stores the keys in a tsm.pwd file. Spectrum Protect server uses AES encryption with a minimum length of 256 versus the client, which can use AES 128, 256, or does 56-bit. For server-side encryption, the server signs the encrypted data so that it can test to see if it's been tampered with or corrupted. The client does not have this signing capability. The biggest difference is that on the server, data that's been encrypted will have first been deduplicated in the container storage pools. Versus if you turn on client encryption, we cannot do server-side deduplication on data that was encrypted at the client. In the Operations Center, when you set up a cloud container, you will be prompted to turn on encryption. Another thing that it's going to prompt you to make sure of is that your database backup is occurring and that you've done your setDB recovery for the cloud encryption. And these are really important because if you lose your Spectrum Protect database and have not backed it up, you're not going to be able to restore that data that was encrypted. We don't have the keys. That data is meaningless to us. So it's extra important to make sure your Spectrum Protect database is being protected. Let's take a look at how to protect the container storage pools. I'm going to talk about the new Protect Storage Pool command, replicate node, and copy to tape. So with container storage pools, the best way to protect the data is through replication of that data from one Spectrum Protect server to another. For traditional legacy storage pools, we use the replicate node command to do this. And that will basically replicate the backup and archive data from the primary server over to the target server. Well, with container storage pools, we've introduced a new command called Protect Storage Pool, type equals REPL server. This Protect Storage Pool command replicates only the data, and it replicates it at an extent level. And so this replication actually goes very rapidly. Currently, this Protect Storage Pool command is only for directory container pools, not for cloud container pools. And it does require you to have a replication schedule. And so as you set up the directory container pools in the Operations Center, you will be prompted for this replication schedule. And we recommend that this Protect Storage Pool command be run often enough to keep up with the pace of the incoming data from your backups and archives. But it needs to complete prior to your node replication starting. You have to run your node replication in conjunction with your Protect Storage Pool. Remember, Protect Storage Pool is only replicating across the data extents. You still need the replicate node command to run to protect the meta information. So if you do not run the replicate node, that data that you replicated with the Protect Storage Pool is useless. So some of the limitations on using node replication is that the cloud container storage pools can be a destination pool for the target replication server, but cloud container storage pools cannot be a source storage pool. And for redundancy, you might want to use replication capabilities available from the cloud storage provider if you're interested in how to protect cloud storage pools. So one way to protect the directory containers is with the Protect Storage Pool in combination with a replicate node. Another way to do that is to create a copy of your directory containers out to tape. This can be used as an alternative to replication, or it can be used in addition to replication. So you could have one copy of your directory containers being replicated to a secondary Spectrum Protect server and an additional copy going out to tape. Or you might not have a secondary server and all you want to utilize is a copy out to tape. This copy to tape for the directory containers is not the same as your legacy storage pool copies. When we copy the data to tape, we leave it deduplicated. And so the only way to really use those tape copies is to use them to repair or rebuild your directory container. The clients cannot currently directly access the data that's on these directory container copies out on tape. So if your client needs to access data that was lost because your directory container was damaged, you will first rebuild or repair that directory container from the copy to tape. So these replications to tape use a new storage pool type called copy container. The copies are actually created as part of the existing protect storage pool command that we just talked about. And the copies are only used to repair or rebuild the directory container pool. The copy to tapes don't use the traditional reclamation process to maintain and get rid of half-empty tapes. Instead, the reclamation for our copy to tapes for directory containers runs as part of our protect storage pool command. First off, the copies to tape are performed incrementally as part of our protect storage pool type equals local process. And the copy container is going to be used to repair the directory container only when we run this repair storage pool source location equals local command. Your Spectrum Protect database obviously has to be up and running prior to being able to run this repair command. So if you did have a complete loss of your primary Spectrum Protect server, you would first of all restore your Spectrum Protect database, and then you would go through this repair storage pool command to restore and repair and rebuild your directory containers. When we're doing this repair command, we will utilize on-site volumes first, and then we'll issue the normal ANR 3425W warning in the activity log to request that offsite volumes be brought back on site. Space reclamation is actually performed for these directory container copies to tape as the protect storage pool type equals local process, and we don't have to mount the half-empty tapes. In fact, we will simply take the existing valid data out of the directory container and recopy it out to tape, and then free up those tapes that have been specified for reclamation. Now in 8.1 we made some enhancements to this tape copy reclamation for the directory containers. When we do this protect storage pool process, there's actually three pieces of it. First of all, we go through the delete phase where we apply any expired extensor chunks to the existing container copies. Then we run the main protect, which is going to look for new or unprotected extensor chunks which need to be copied out to that tape. And finally, we run the reclamation itself, where we look for filling our full container volumes that we could reclaim. So we have a new option in this protect storage pool command, type equals local. We now have the reclaim equals yes, no, only limited, or yes limited. So if it's no, then the protect storage pool will not run reclamation. If it's only, then the protect storage pool will not run the main protect process. It's going to skip that. If it's only limited, we will basically run reclamation, except we'll stop it when we hit the reclaim limit. And if it's yes limited, then we still will run the main protect, but during the reclamation process, we'll stop that when we hit the reclaim limit. Now the reclaim limit is set as part of our define or update storage pool command, and it basically specifies the maximum number of volumes in the container copy storage pool that are reclaimed. And these options were introduced in version 8.1. If you want to set up the directory container copy to tape via the Operations Center, during your add storage pool for that directory container, you will see the option to copy data to tape. If you want to add that to an existing directory container, you could go into the storage pool panel, click on more, and issue add container copy pool. Now VTL and file are not supported devices for these copies to tape. And when you set up this schedule to run the copy to tape, the initial copy to tape might take more than the amount of time you have available the first day. And so it will actually schedule it to run over multiple days. When we initially set up this copy to tape, we give it 8.5 hours by default. This would be 8 hours to run the process and then half an hour for cleanup. And the start time is based off of when your database backup kicks off. By default, your reclaim threshold is going to be set to 90%. So what that means is that tape won't be reclaimed till 90% is dead data. Here is the command line for your Protect storage pool, if you're interested in issuing it manually. And you can see we have the Protect storage pool type equals REPL server. That would be if you're replicating the data. And remember, this is only the data extents. In order to get the meta information, you got to run the node replication in addition. Or if you're doing the copy to tape, that would be the Protect storage pool type equals local. Now, in order to repair the data, if your directory container does become damaged or destroyed, we can either repair just a few damaged extents or we can repair the entire directory container pool. When you run this from a replicated copy, the Protect storage pool has to obviously have access to the secondary server. The target server on the secondary server must not be damaged, and there has to be a network available between the two Spectrum Protect servers. And your basic command is going to be repair storage pool. The storage pool name, source location equals REPL server. If you wanted to run that repair from a tape, then your command is going to be repair storage pool, source location equals local, and then you have the options of preview equals yes or no and wait equals yes or no. The way this works is that we will look for volumes that are on site, and we'll select the data from those on-site volumes first, and we'll mount those and repair the damaged directory container pool. If they are off-site, we do ask for those volumes to be brought back on-site before we proceed with the repair. Okay, so I just talked about the ways that you can protect a container storage pool. The first being your Protect storage pool command that would be run in conjunction with your replicate node. And then secondly, you could also do a copy to tape. Now let's take a look at Aspera FastP. Aspera FastP is WAN optimization. We can utilize it with node replication and Protect storage pools currently for X Linux. This code has been built into the Spectrum Protect server, and it does help to optimize the data transfer by improving the data throughput in a WAN where your network is compromised by high latency or high packet loss. So FastP can also utilize the SSL and Aspera AES 128 encryption that comes with the Aspera FastP. The way that you know that it might be of assistance in your environment is that if you do have an impaired network where your latency is greater than or equal to 50 milliseconds and where your packet loss is greater than or equal to 0.5%. FastP does have to be licensed on both the primary and target Spectrum Protect server, and we currently only support it on X Linux servers for directory container pools, version 7.16 or later, in conjunction with our Protect storage pool and replicate node commands. Finally, let's take a look at how you would take existing data that's in legacy pools and convert it into our new container pools. Directory container pools, we have the ability to run this convert storage pool command from either file and VTL. This would be in version 7.16 and above. And that move data is going to convert it from a legacy pool into a container pool. It will work for both file and VTL pools. One thing we cannot convert is NDMP, TOC, or virtual volume data that might have been stored on those file or VTL pools. And when we run this conversion, we do dedupe and compress the data on the fly as it's written into these directory container pools. Starting in version 8.1, we open up that convert process to also include file, VTL, or tape storage pool. So the new piece here is tape being converted into directory or cloud. So the new piece is cloud containers for version 8.1. The process is basically the same. The easiest way to kick that off is to go into the Operations Center, into storage pools, click on the More, and then click Convert. You will need additional space on the target pool. If the source pool is a file pool, we suggest the target pool has 30% more free space than was used on the source pool. And if the source pool is a VTL or tape pool, we suggest the target pool has more free space than used on the source pool. You probably want to schedule this, so when you go through the Operations Center wizard, we will set up a schedule that will run over multiple days, and it'll just run during that period of time when those resources are not busy. So for a conversion to a directory container, you might be able to run that nonstop. But if you're converting out to a cloud container, you probably don't want to run the conversion while your backups are running, because they'll be competing for the same network. When the conversion from tape runs, we do choose the tapes with the most reclaimable space to be converted first, and we use as many drives as are specified on the number of server processes when you set up your Operations Center wizard. If you want to run the command via the command line, it's a convert storage pool, source pool, target storage pool, max process, and durations. You will see in the activity log messages about the volumes being opened and closed and deleted, same as you would for your move data. This is basically move data underneath the covers, with a few caveats that we're doing things like deduplication and compression, and if it's going up to the cloud, perhaps even encryption. Once the conversion completes, it may find some inconvertible data. This is data that might have been damaged. It might be data that was either a table of contents or NDMP data. And so you can do this query cleanup with the storage pool name, and that'll show you the details of what has not been converted. You can also do the remove damaged, where you say, you know what, just go ahead and remove that information. Or you could retry, you could repair those damaged files and through a restore or repair, and then retry them. You can always issue the query conversion, and that'll show the status of the conversion, as well as the query storage pool format equals detail, which will show you the conversions that are active, the conversions that are inactive, the conversions that have completed but need cleanup, or the conversions that are fully completed. Inside of the Operations Center, when you do this convert storage pool, you will be prompted for the storage pool you want to convert and where you want to convert it to. You'll be prompted to set up the conversion schedule. Inside of the Operations Center panels, you'll be able to see both your destination storage pool as well as your source storage pool. The destination storage pool, which will show if a conversion is in process. The source storage pool will show if the conversion ran on that specific day and the amount of data that was converted on that specific day. We can also drill down into the unconverted data screen, and this will show the files that we could not convert, and it'll give you the option to either retry that conversion or delete those files. So what I just covered was Spectrum Protect containers and how they are a new methodology for storing data that brings about enhanced performance, simplicity, inline dedupe, and the ability to write data out to cloud. We do have other videos and demos out on YouTube in regards to the containers, so please do take a look at those. Thank you.